Hi students, welcome. In this video we will study about rotational flow and irrotational flow. So let's first see about rotational flow. Here there are two diagrams. Let's first see this circular streamline diagram. Here as you can see here, this first here this is a streamline, and in this streamline the fluid is flowing, and this AB is a fluid particle. Okay, and while flowing this fluid particle in this streamline, as you can see here, this fluid particle is also rotating about their own axis. That is, in this case it is rotating it as anti-clockwise direction, in anti-clockwise direction, as you can see here, and this is the vertical position. In this position, topmost position, the name, as you can see here, AB is name, as you can see, and when it goes to this second position, as you can see, the nomenclature has changed. That is, it has rotated. A comes to the leftward position and B at the rightward position, and now again at this point, that is third position, as you can see here, B is at the top and A is at the down, and at this fourth position, as you can see here, A is at the right hand side and B is at the left hand side. That's why, as you can see here, while this fluid particle is flowing in the streamline, it also rotating about its own axis, as you can see here. Now let's see the second example. As you can see here, this is a streamline, and in this streamline fluid particle is flowing. As you can see here, in this case also, fluid particle is rotating about its own axis in anti-clockwise direction. At this first position, as you can see, first at topmost position A, and at the bottommost position there is a B. Then after rotating it, at the leftward position there is A, and rightward position there is B nomenclature, and further, due to this anti-clockwise motion, at the topmost position there is B, and at the bottom there is A nomenclature. Again, due to this rotation, leftward position has B nomenclature, and rightward position has A nomenclature. So in this case also, this fluid particle, while flowing in the streamline, is rotating about its own axis. Okay, so students, so when fluid particle is flowing in a streamline, it if it is rotating about its own axis, then that flow is called as rotational flow. Okay, now see here, the flow in which the fluid particle, while flowing along streamlines, also rotate about their own axis, is called as rotational flow, as we have seen. Further example, the whirlpool formation in the river, the motion of the liquid in a rotating cylinder, forced vortex. Okay, now let's see the irrotational flow. As you can see here, here also there are two examples. Here first we will see this circular example first. As you can see here, in this case also, fluid is flowing in a streamline, and here this is a fluid particle, as you can see, AB. When and in this case, as you can see here, at each position there is the same nomenclature. That is, at topmost position there is A, and bottommost there is B. So as you can see here, in this first, second and third and fourth, all these fourth conditions of the fluid particle has the same nomenclature, and it is not, that's why it is, that is, it is not rotating about its own axis. Okay, so we have seen here, now fluid particle is not rotating about its own axis while flowing in the streamline. Okay, now in the second case also, as you can see here, fluid is flowing in the streamline, and here it is a fluid particle, and as you can see here, here also there is no rotation of the fluid particle. Okay, as we have as you can see here, AB, A is the topmost nomenclature and B is the bottommost nomenclature in each this first, second, third and fourth position of the particle also. So here, as you can see here, the flow in which the fluid particle is not rotating about its own axis while flowing in the streamline, then that flow is called as irrotational flow. Okay, now see here, the flow in which the fluid particle while flowing along streamlines do not rotate about their own axis is called as irrotational flow. Okay, now further example, general pipe flow of liquid in an emptying wash basin, free vortex. Okay, that is called as here irrotational flow. Further, now see rotational component. Here rotational component is denoted by omega, which is equal to half, and here this is modulus. Okay, in this here you can see ijk dou upon dou x, dou upon dou y, dou upon dou z, and uvw. This is the rotational component. And further, let's simplify it. Omega x is equal to half into bracket dou w upon dou y minus dou v upon dou z. That is here this is cross multiplication of this and minus then this. Okay, here now second is here omega y is equal to half into bracket dou u upon dou z minus dou w upon dou x. Omega z is equal to half into bracket dou v upon dou x minus dou u upon dou y. Okay, and when for and condition for irrotational flow is here omega x is equal to omega y is equal to omega z is equal to 0. Okay, then the flow will be irrotational flow. Okay, so students, in this video we have understood about rotational flow and irrotational flow. Thank you students for watching this video. Like, share and comment for this video and subscribe my channel. Thank you.